Hello all my audio friends out there. So we have our next project to put on the bench, and it is a Carver model M500t, and as you can see, the front of it's all smashed up. And unfortunately, when this thing shipped, it was in really nice condition. Very, very good condition. And this is a result of what happens when you do not pack a product properly when you ship it. Now, I'm not going to get too much into that because there are plenty of other people who have kind of reviewed that, and so I don't think I need to go over that again. But again, when something's not packed properly, unfortunately, you can have a really nice piece of equipment and have it damaged. But what we're going to do on this is we're going to replace the faceplate with a new aftermarket one, and they are really high quality, and they look a lot nicer than these silver ones, in my opinion. It's one of the black faceplate ones. So maybe it'll work out to our advantage. But if that sounds interesting to you, stay tuned, and that's what we're going to do. Hopefully this won't be a real complicated project, but famous last words when we say that, huh? I don't know anything about the history of this, other than somebody sent it to me, and I got it a while ago. It's been sitting, as you can imagine, how many projects are backlogged. So we're going to get this one and see if we can bring it back and make it look nice and make it play nice and give it some tests. Okay, we have the top off. You know my rule. I don't plug things in until I check them. And of course, this thing is plagued by the glue monster again. And pretty much anything from this era by any manufacturer is going to be susceptible to the glue problem. So we'll have to clean that up. Okay, our first problem. So I turn the power on. Ready? Click. And you can see the little light here down in the corner. See right there? It's on. It just turned on. This thing is very intermittent with the DC or with the protect relay not coming in. There, it just kicked back out again. Just went off. And I'm getting no output whatsoever. So that's telling me that there is a problem with our power supply. So we're going to have to do some measurements. Okay, so I'm doing some preliminary power tests just on the power supply, and I am getting bumpkus everywhere. So I believe this is your plus and minus 70 volts here. And there's negative 1.3 on one side, and there is positive 0.3 on the other side. So I hardly think that's going to do us much good. So we have to find out what's going on now. So do we have a bad winding on the magnetic field transformer? If so, this will then be a device for maritime use only, as its only purpose in life at that point would be boat anchor. So let me check a little bit more. Oh, I love the smell of electrons. So, got this set up. First of all, I'll show you in a minute, but I got the meter on, and the bridge rectifier is literally so loose, the mounting on it, that's falling off. I don't know that that's the issue or not, but I pushed this power button in. I got a big, nasty white spark, and smoke came rolling out of the switch. And I think part of our problem is a faulty switch in this thing. Wish I could have got that on video. We all love things. I mean, it was, I mean, you know, images of electro boom. It was that good. Anyway, so we're going to have to resolve the problem with the power switch first. The other thing, like I said, if you look right there, and the transformer doesn't, sometimes it buzzes, sometimes it doesn't. And if you look down in here, this thing's just like flopping around in the breeze. It's loose, you can see. So I don't know.
What's the matter with you? I'm trying to think, but nothing happens.
But we're going to have to take this apart further and kind of see what all's wrong with it. I have a fear that there might be something wrong with the transformer, and that's why this thing got sold in the first place, but we'll see. Of course, another nice modification to this is the addition of black electrical tape that I guarantee you is not factory. Somebody has been in here doing something. We don't know what, but yeah, gross tape. Yep, famous last words, guys. What did I say at the beginning of this video? Bohica. All right, here we go. We'll get the switch taken out and see what's going on. All right, this is just total awesome sauce. So the first thing that is good news is that this switch is perfect. There is nothing wrong with the switch. It is working just fine. However, we have these power supply transistors down here, and I'll show you on the schematic where they are. They are these guys right here. And you guess they are directly in the power supply, and they actually are for your 37.5 volt plus and minus rails. This one is dead shorted, and we can demonstrate that. Hold on. We'll get the meter over here and go from this pin to this pin, and you can see she is dead shorted. But the really cool thing is that there's two of those in here, and here's the other one. And as you can see, this is one of them is obviously a replacement because they're not the same. But even better, somebody just stuck wires on it, because this one was a pull from another unit and the leads were cut short, so they actually just kind of bodged on some wires across the top. So this was a used transistor to begin with. You know, strangely enough, it's not reading shorted, but we're going to test it on the transistor tester just real quick, but it doesn't matter. They all need replaced. But yeah, I thought that was pretty interesting. So we have a shorted transistor which is holding down the power supply. At least that's part of it. The other thing is, I know this is a factory mod, but originally this was fitted with 4 fuse holders for fuse protection, and you can see they've been eliminated because technically the protect circuit should shut everything down, but you know me, I'd rather see the fuses in there. It could never be too safe. But anyway, we're not going to worry about that today. We're going to worry about finding some transistors. Okay, so we had to do a little bit of research, and the 2SD1047 and the 2SB817 are a matched, complementary pair of transistors. And the one thing I noticed that stood out about it was the transition frequency was 20 megahertz, which is pretty high on an output transistor like this. Now, the cool thing is I have a whole pack of these great big heavy duty what were they? MJ21193 and MJ21194s. So you could see them right there. And they're actually way more powerful than the ones that are in there. They're really heavy duty. But, and here is the issue. When we go over and look at those, a good thing I looked it up, you can see down here that the transition frequency is only 4 megahertz. So I ended up looking through my stash and I found these NJW1302Gs that I had in my stash here, and I had enough left over to do this. And I had their complement, which was the focus in NJW 3281G. And I had two of each of those. Actually, I had a couple more than that. And when I looked them up, you can see they're a complementary pair as well. They have a transition frequency of 30 megahertz, which is even higher than the other. Now, why does that even matter on this output? Because, again, these are power supply transistors. They're not the outputs. And even if this was a high-speed DC amplifier like that Sansui we worked on, why would we care? Well, I'll show you why I'm a little bit concerned. It may not matter, but since I'm not sure, I'm going to kind of err on the side of caution. Let me show you the schematic. So I'm going to hold this just because I don't feel like repositioning everything and moving everything around. But here's the schematic of the power supply. And believe it or not, the power supply actually can vary with the amplifier. What do I mean by that? Well, this is another one of those Class G or Class H amplifiers, where I believe the Class G is where you have output transistors that each output transistor is set at a different voltage on the collector, and you switch the higher voltage rail transistor shifts in, as the amplitude increases with volume. Whereas the Class H, you actually have the power supply itself will switch into a different voltage as the output transistors of the amplifier require it. So what's happening is you have two different power supplies. You have a plus and minus 40 volt supply and a plus and minus 74 volt power supply, and the switching takes place. You see the steering diode, which steers your 40 volts and isolates it from the 74. And then you have this little transistor circuit that, as we cross over that 40 volt range at a certain point, the 74 volt rail will start to phase in and go into here and carry the rest of the signal from there. Now, there's a lot of advantages to that, but I'm not going to really get into it on this video. But the bottom line is that whole process of switching has to take place very, very quickly. And although we may not have a 4 megahertz or 20 megahertz or even a 4 megahertz signal, the problem is that transition frequency also dictates how fast the rise time is. In other words, how long it takes a transistor to react and turn on. You have to remember, this transistor has to switch between the two power rails very quickly. It's in the middle of a cycle. In other words, the sound is coming through, the audio is coming through, the amplitude is rising very quickly, and it has to, right mid-stride, switch over from that, kind of switch in that 74 volt supply. So the rise time is very important, and conversely, as this amplitude is decaying, it has to be able to shut off very quickly. And that's why I think they use these special transistors with higher transition frequency. So I was a little bit remiss to try using these, even though they were less expensive, and I had, as you can see, I have a whole bunch of them in stock. And these are very robust. They don't burn out. They can take a lot of current. But again, with the 4 megahertz transition frequency, I don't think the rise time will be quick enough in some instances. And the last thing we want to happen is have the rails not switch quickly enough. So we're just going to use those ones I had, which are actually superior. And these are, I believe, a 200 watt? I think these are rated for 200 watts. And I think these other ones are rated for 100 watts. I think they're lower power. So we even have a higher power. Everything's good. The voltage is good. Everything specs out. So I think we should be good. So I'm going to put them in. Okay, we're in the process of replacing these, and just a couple notes I want to give you guys, something different. Well, first of all, several of these screws were stripped out, so they weren't even tight, which is part of the reason probably that these things failed. So what I ended up doing was I just put a longer screw in there, and then just put a nut on the back of the heatsink to tighten it down, and that took care of that. But another thing I wanted to bring to your attention is I'm using a little bit different thermal pad this time. It's right here, and these are a ceramic. They're a special ceramic pad, and the funny thing is when you pick them up, they're really cold to the touch. These are really heat conductive. They conduct heat very well, and they're brittle. You can crack them, obviously, but one of the advantages is if the surface is flat enough, like on the back of these transistors, you almost don't even need heatsink grease. And if you use grease, you use very sparingly, very thin coat. And they're very high dielectric content and very good conductor of heat. So I think they'll work really. I had several of these left from another project at work that I was doing. So I figured since I had them, I'd use them, because I'm kind of running low on the mica pads for these cases. So we're going to put those in. We got the first two mounted up. We're going to get the other two in, and then we're going to see if this thing turns on. So I'm finishing soldering in the transistors, and I look down here on the board, and lo and behold, look what I see. Check that out. Right there. Big old crack on the board. Luckily, it's just catching the corner of this one trace, and I think I can fix that. So we're just going to put a patch on there, and I think we're going to call it a day on that one. We're lucky it didn't go anywhere else. I think this amp's been rode hard and put out wet by the looks of it. Okay, so this thing's turning out to be a little more of a problem than anticipated. We rebuilt the board, put the new transistors in, and put the switch back in. And I just was going to do a quick power up just to make sure everything's working. And I noticed that this transformer was getting very loud, and it was ramping up, more and more, trying to build current. So I kind of got the impression that something is not right. So on the schematics, you have two main power supplies, I guess you could say. You have your plus and minus 40 volt, and you have your plus and minus 74, and there's two of those. There's a low current 74 volt supply, plus and minus, and there's a high current plus and minus 74. And essentially what's happening is for the high current plus and minus 74 volt, that's this bridge rectifier that's very loose in here, kind of falling off. It's come loose. And then for the low current plus and minus 74, we have this little tiny bridge rectifier here that you almost can't see on the camera. It's kind of stuck down in there, and it's just a little flat pack one that's right on the board. Now originally the fuse sockets were omitted from this board, probably a production change that they made, but what I found is that all the safety circuitry in this power supply does not deal with an overcurrent situation like this. So really, it is a good idea to have fuses. I have a whole set of brand new fuse sockets that fit right in here perfectly. So I soldered them in. Now the ones on the low current supply for the plus and minus 40 volt supply are right here, and I've already fitted the fuses. These ones I've left the fuses out, and if I leave the fuses out on the high current plus and minus 74 volt supply, the amplifier powers up. At least we get the plus and minus 40 that we need. And it's running a little bit low, but that could be because the adjustment is off. So we're not worried about that. So what I'm driving at here is it looks as if we have a short circuit or a high current situation in the power supply up here. The other thing I noticed while I was underneath there kind of fixing up the power supply board, let me get on the other side here and we'll show you. So taking the 30,000 foot view here, here's your one channel and your other. So you have your left and right channels here. And I noticed something while I was under here that looked kind of strange. First of all, you can't go by the flux on the boards because even the factory jobs, sometimes it leaves flux on the boards, but these just kind of looked like they'd been worked on before. Then when I looked more closely, if we look up here, look at these transistors, look at the part numbers, 2SA1011, 2SA1095, 1095, 2SC2565, 2565. If you go down to the other channel, these ones are 2SD845s. These ones are 2SB775s. This is a 2SA1111. So none of the transistors between the two channels match. Now I went online and I looked them up. And actually, these are high frequency transistors. But the transition frequency is different between them. So for instance, these are the original ones that came with the amplifier. And they have a transition frequency of about 20 megahertz. And they're rated at 120 watts. And they're rated for, I think, like 150 volts for the collector to emitter voltage. Moving up to these ones, they look like kind of a more robust version of the same thing. Instead of 120 watts each, and they are complements. So these are complementary pairs, so that's all good. But instead of 120 watts, these two SA1095s and two 2565s, these guys here are rated at 150 watts, so they're a little more power. 200 volts instead of what it was, 150 or whatever. And the transition frequency is 30 megahertz instead of 20. So really this is more of a modern update of these ones down here. So it looks as if these have been replaced. So at some point in time this channel over here has been serviced, at least from what I can tell. The other thing is there's a field note for the power supply. The capacitors down in here, they actually put the vent for the capacitor. Should the capacitor fail and it vents, it'll vent its gases out. It actually has the vent on the bottom where the pins are. So what Carver is recommending is that you remove the capacitors and you shim them up with some nylon washers to give them room in case the capacitor should fail. They won't explode. They'll vent out the bottom. So all of those things don't really give me a warm, fuzzy feeling. So we will eventually be taking care of all that. But for right now, I'm really interested in finding out what is causing that short on the plus and minus 74 volt high current power supply rail. And those are coming up into here. They're all wired in from the bottom. So we're going to investigate all this and try to figure out what is going on here and what we can do to fix it. So that's our next step. Okay, I removed the transformer, and boy, the screws were loose on that, and they were loose on this one. I mean, all these screws were loose. I don't know that that was 100%, the previous owner. Some of that, I think, had to do with the big crash that this thing took that broke the faceplate on it. I think the cracked circuit board, as well as the transformer, screws being loose and the hardware in general being loose, part of that had to do with the rough handling this thing received in shipping. So that's part of it. And this thing was just literally thrown in a box with some shredded paper and things. It really wasn't packed very well, so it's a miracle it made it here at all. And I'm sure it looked beautiful before it shipped. So, I mean, other than we couldn't see the dirt inside, but that, neither here nor there. But anyway, we have this out, and I can definitely say this is a strange circuit. If you look, you have a red and an orange wire for your plus and minus. However, if you notice, the orange wire is on the plus and the red wire is on the minus. And if you follow them onto the circuit board and you compare it to the schematic, the wires, even though the color doesn't seem, seems counterintuitive to what you would think, they are going to the correct part on the circuit board. So that was another strange thing. The other thing I noticed is looking at the soldering job done on this, you can just kind of see down here, look at how messy that is. If it'll focus, I might be a little too close. There you go. I mean, if you look at that, it's really bubblegum solder. So somebody has either taken this out at some point in time or replaced it or something. I'm not sure. It doesn't seem to read bad, but I am going to remove the wires to check it properly and make sure there's no problem with it. But there is definitely something in here there's no short when you don't have power applied to it. But as soon as you apply power, it starts to short out. So it could just be a really severely leaky capacitor. I don't know yet. But we're going to just keep investigating. Okay, so the bridge rectifier was perfect, so I just cleaned it really well. And I took the time to kind of clean around the power transformer and everything. I put it all back together. I did notice that these screws were pretty much stripped, which was why they were so loose. So I ended up having to put nuts on the bottom of the 4 screws for the transformer. No biggie. This thing must have really took a hit when it was shipped. So what we're going to do now is we know where the short is, because we know if we disconnect that plus and minus 74 volts high current supply, our short goes away and the amp, the triac and the magnetic field controller and all that stuff works, and we get our plus and minus 40. So what we're going to do is we're going to I'm going to show you a technique I use. This is kind of cheating in a way. We could go through and logically trace each transistor, but sometimes when you have a stereo amplifier, it's a lot easier. There's an old saying that we use at work that says, show me where you've been and I'll show you where the problem is. And what the meaning of that is wherever there was a problem somewhere before, where there was, somebody worked on it or did something, there's always a probability that if there's an issue, that probably that problem is going to be related to that. So we know that down at the bottom we had that bad transistor, and it was one of the regulators for the switching regulators for the 30 volts, plus and minus 40 volts, I mean. And we know that it feeds one of these channels, and it's actually feeding this channel down here. So you can see you've got your plus and minus power going into this channel here, and then you have the same thing up here. So you have a red and blue wire for your plus and minus power on this channel, and you have an orange and brown wire up here for this channel. So all we're going to do, I'm going to kind of go down and move the camera. I don't know that I'll get this whole thing in one shot. We'll try. But if you look here, and I'm going to move away from the microphone a little bit as I'm doing this, so my voice might get a little quieter. You guys like that, don't you? Don't have to hear Tony talking. Anyway, I just have an analog meter here, and there's no reason other than, well, there are a couple reasons. Number one, if you have an analog meter, it makes it easy when you're spot checking for this test, because you can just watch the deflection of the needle and note where it falls on the scale. The other thing is, being a 20,000 volt ohms, 20,000 ohm per volt meter, it has a lower impedance than a digital meter, so it actually puts a wee little bit more current through the circuit when you're testing it to overcome some things. So just for those couple of reasons, I like to use this. You can still do this test with a digital meter, and it'll probably work, especially if you put the meter in either in diode check or in continuity mode or whatever. But we're going to just use the meter. Something different. So all we're going to do is we're going to take measurements on one channel while my daughter sings and acts silly upstairs. And we're going to compare it to the other channel. So for instance, we're going to go between the emitter and base of these transistors and kind of watch where the needle falls. You see where it's going? And see, they kind of match. And then we're going to go to this channel and we're going to do the same thing. And you want to keep your probes in the same orientation in case you're reading through a diode or something. And you can see all four of them, between both channels, they match if you kind of watched what the needle was doing. Hopefully I wasn't getting in the way with my hands. So then we're going to go down and do the same thing here. Okay, so we're just doing emitter and base right now for no reason other than process of elimination. And then we're going to go do the collector. And you can see what we have there. And again, I'm not really paying a lot of attention to the ohms at this point in time. I'm looking more to my needle, how it's reacting, and where it's falling on the scale. You see what's going on? I don't know if I know this lead's a little bit in the way. And then we're going to flip our probes because it's upside down here, right? Do the same thing, and it should basically look the same. You can see we're reading through some capacitors on there. Okay, so those look pretty similar, and I'm not seeing any shorts anywhere either. So not only do we don't see shorts, because if we had a short, it would be all the way over, and which I should probably zero that, shouldn't I? So now let's go to the driver transistors. Same thing. Start with the base and emitter. And we're going to go to this side. And look at that. We got a short right there. See that one? It goes almost all the way shorted. And if we go on this side, yeah, about 550, 560 ohms. So there's a suspect transistor right there. Now remember, these are different transistors, 2SA1111, 2SA1011, and I have a feeling, again, this is just a little heavier duty version, or this one is, I don't know. They've been replaced. So, well, actually this one was replaced, I believe, and this one was not. This is original. So let's just pull this one out, and I'm going to finish testing these last couple with the same methods. If there's no other problems, we're going to pull this one out, and we're just going to put it on the little transistor tester and see if there's a problem. Okay, well, looks like we may have found another one here. On this one, again, we're just going emitter base. We get pretty much an open there. And I'm on R times 100. And you can see I only have about 100 ohms there. So, and on this one, in both directions, it's reading about that 560 ohm range. So there's a problem here as well. So, you see if I can get on it now. I'm kind of behind the camera here. There you go. That's 100 ohms that way and 100 ohms that way. That's not good. and this one is 550 ohms that way and 550 ohms that way. See it? So this one's 100 ohms in both directions. This one's 550 in both directions. Well, I'll leave the camera on. We'll check this last one. That one's a little bit different, but not too much. So these drivers are definitely weird. So we're going to have to pull them at least and test them out. All the other ones look to be pretty good. So let's just pull them and see. Okay, as you see, I pulled this one out because we were kind of suspecting it. And we put it down here on the little transistor tester thingy. I really like these. They're pretty nice. And look what we found. Red and green shorted, which means we have a short between the base and emitter. So there's one bad transistor. I'm going to check the other one now and see what it looks like. Okay, we pulled this other weird one out that didn't look right. And we put it on the tester. No component detected. So guess what? This one's open, this one's shorted. And there you have it. So the drivers are shot. Now here's where we get into that conundrum. We could just replace those couple of components and test it. We can also go on and kind of statically check all the other small components on this. But here's the thing that I've found out through the years is that even if replacing these two components makes the amp work for now, chances are in a direct coupled circuit like this where you don't have capacitive coupled components, every time you put a short or high current situation on one transistor, all the ones down the line that are connected to it are also subject to that high current situation. So even though the transistor may work now, it may develop a problem and either open or short or go leaky shortly down the road. So that's not something you want, especially when you turn this over to someone that is not technical, that just wants their amp to work for a long time. You know, it's a big hassle for someone to bring their amp in and have it repaired or ship it in or something. It costs a lot of money, and therefore, in the long run, it's more economical to replace all the components that are related to it while you're at it. Now, that's an added expense up front, but really, it's kind of an investment in the future if you're planning on keeping this for a long time and if you're planning on, you know, using it. In some instances, it's not worth it. You know, on a smaller amp or a smaller device, you really don't want to do that. But again, it's a case-by-case basis. But I'm going to do some more testing. I have a feeling there's going to be more wrong than just that, because usually when you have multiple components failed, there are more down the line that are bad as well. So I'm going to keep going, and once we get everything put back together, we'll come back. Okay, so as it turns out, we had this one was shorted, this one was open. Everything else looked okay. So I went ahead and I replaced these three here, and just so they match, I replaced these three up here, even though these ones tested out good. I pulled them and tested them. This channel really didn't seem to have any problems. It was all down here. So what I did was I ended up finding some suitable substitutes. Those 2SC 25, what are they, 2590 ones and 2SA 111 ones are getting pretty hard to find. I mean, you can find them here and there piecemeal, but it's kind of tough. So what I ended up using was, these were almost a perfect match as far as transition frequency, voltage, wattage, everything. I ended up using these Sanken ones, and they have the isolated tabs, meaning the whole case is made of plastic on them, so you don't need to use the insulating pads or any of the mica pads, which for this application is perfect. And down here I used a 2SA 1859 for the PNP, and I used its complement, which is the 2SC 4883 for the NPN. And then for this one down here, I used one of those Toshiba TTC004Bs, which are the same ones we used for this type of transistor in the Sansui AUX1 video. So I had a bunch of these, so they were, again, perfect match. So this all looks good. Turning the amp around and looking at the front, let me get you repositioned here. So as you can see, we got the power supply rails, these rail switching transistors. They got all replaced. And what did I use on there? I used the, I can't see. How about I zoom in with the camera and we just kind of see if it'll focus. There you go. NJW3281G for the NPNs, and panning down, NJW1302Gs for the PNPs. And then I use those same little isolated tab transistors as the other side for the drivers for those. So those are all replaced. Again, there was stress under there, so, these were stressed out. I replaced them. I don't want them to short out again down the road. And as you can see, we put the fuse holders in there, and that's nice because that way if one of these shorts out down here, one of these transistors down below, hopefully we'll be able to go ahead and just pop a fuse in there, and it'll kind of hopefully limit the damage, of something shorting out. Again, this is not a restoration video. I just thought I'd throw this one up there for kind of some troubleshooting techniques. I'm going to turn this thing on now and see if we have power and if it works. If it does, I'll finish the amp up and then we'll come back and give it a listen. Okay, so we got the meter connected to one of the 74-volt rails, and we're going to plug it in here, turn it on, and hopefully not blow any fuses. All right, here we go. Ooh, wow, the protect relay kicked in. Great. And as you can see, we have 78 volts. So it's a little bit high, but I believe that because it needs adjusted, these new transistors may be a wee little bit different gain or whatever than the old ones, so we just might have to adjust the power supply a little bit. But man, look at that cap holding a charge too. That's great. We're even all unplugged and it's still holding a nice charge. So wow, the protect relay came in, so I think we can actually test this thing out, and it should work. So I think it's fixed. So let me finish things up here, and I'll go through it and do an adjustment on it, make sure the voltage is correct and all. There's just one pot for all the power supplies combined, which is this little pot right in here, and you just adjust that. I think all you do is tweak that till you get the correct voltage, whatever they tell you at the test point. So I'm going to do all that, and then we'll be back and put everything together. And there we go. So there we go. Quick video, just troubleshooting and repairing an amplifier. It's working good. So we're off to the next project. I have quite a few. I'm not sure which one we're going to do next because literally I have a whole pile of them to do. I have some really cool stuff, but I don't know if I'm going to go in. I'm going to probably do some smaller projects for right now because I'm so busy with everything else. We're just going to do some small things, and we'll save the bigger projects for a little bit later when things slow down. All right. Hope you all enjoyed this quick video. And as always, I wish you all peace, joy, happiness, and good health in your lives. We will see you again very soon. Take care. Bye-bye.